In this section, we're going to be doing image classification. In doing image classification, we're going to determine what different things are within the image. This could be done with Sentinel, our Landsat data, our aircraft data. In our case, we're going to use 2019 aircraft data from December at 3-inch resolution of Jefferson County, Kentucky. We will take the image service, clip it, and then do an analysis. We're going to start this process by making a connection to an image server. And so I'm going to go over here to connections. I'm going to say new ArcGIS server, and I've already copied the hyperlink, so I'm going to just paste it in, and I'm going to say OK. Then I'm going to go to map, add data. We're going to add that data from a server, and it's going to be the image server I just connected to. And we want to go to image services. And I'm looking for 2019 data that was flown of Jefferson County, Kentucky. There it is. And I'm going to say OK. It'll take a moment to load. And we're going to zoom into this data set. And you can see this data set is for all of Jefferson County. Well, that's much too big of an area for us to work on. It would take a lot of processing power and be very slow. So I'm going to choose a small area of the county. I'm going to come over here to the south central part of the county. I'm just going to scroll in a little bit. It takes a moment for the server to react to this, and we're going to just scroll in and pan as we need to. And get a fairly small area. This is an area of a golf course in the business airport. Give it a moment to catch up. There we go. And you can see we've scrolled into this. And what I'm going to do is then I'm going to export out this map. So I'm going to export the raster. We've clicked export raster. We get this type of a look. We're going to come in here and tell it this is this golf course that we're looking at. It wants to know what's going to be the clipping geometry, and I'm going to say current extent. So what's on my screen right now is what I will be using. I'm going to say export, and it will export this out. It'll take a few moments to do this export. When this is completed, it will add the file into my table of contents. It's now been completed. To show that it's been completed, I'm going to zoom out a little bit. I'm going to turn off the service. And now we can see just what has been exported. So we don't need the service running any longer. We are going to just work with this image that we exported. All right, we've clicked on appearance. We're going to click on the pull down for band combination, and we're going to choose color infrared. And notice what we have done now is a color substitution. We are making what was band 4 of this aircraft image, which is the near IR. We're making that band 1. Band 1 becomes band 2, and band 2 becomes band 3, and we're not using what was band 3, which is the blue color. And so you can see the vegetation pretty well. You see these kind of strange areas here which look to be no vegetation. They actually are the fairways of the golf course, and we'll discuss a little bit about those in a moment. If we click on the symbology button, You can see our band substitution that we did. You can also do things like with the stretch that Nicole talked about. And so you can see all the different choices. Like if I chose standard deviation, it's going to change what the appearance is, but it's going to change where the border lines are. You can also look at the histogram of this and see what's in band 1, where the peak of it is, and so on and so forth. So you can use symbology to modify the appearance. It should not be modifying the data. Again, we can change to a minimum maximum and we get a slightly different appearance, and go back to the percentage clip, which is where we started, and that probably gives us the best appearance of what we have. Let's go back and change the appearance. We're going to go back to band combination and go back to natural color. We've selected the classification wizard. We're going to use unsupervised. We'll see the difference with supervised in just a moment. We're going to do object-based. Object-based means that we're looking at a cluster of pixels and not a single pixel. Our other choice would be pixel-based. For our classification schema right now, we're just going to use the default schema. And we taught where to save it, and we do not need to worry about the last two. We're going to click Next. We're not going to worry about segmentation yet. We'll look at segmentation in a few moments. So we'll click Next. And we're going to leave it with the ISO cluster. You can see it's now classifying things together. And we're going to run this. It will take several minutes for this to complete. As you can see, it has completed the task. It has chosen a set of ramp colors, not necessarily what I would have chosen, and tried to group things together by their appearance. So things that had this much red, this much green, this much blue, it then chose to make a certain class of items. As you can see over on the left here, it's made 5 classes here. We've got this green class that looks to be pavement. We've got this blue class which appears to be most of the vegetation, and so on and so forth. Actually, this pink areas here are shadows from the aircraft. If you look at the image very carefully, you'll see the actual tree is right here, but this cone that goes on up to the upper left corner is there because of the shadows. So this is a classification that was done, which was based upon the computer deciding what should be grouped together. We're going to turn off that layer and the segmentation layers that it created and go back to the original natural color imagery. Okay, we've turned off the other layers here. We're going to select our image layer here. We're going to go under classification tools. We're going to go under training sample manager. It brings in the NLCD 2011 classification. Okay, we're now going to create a couple new classes. So we're going to come up here, right click, say add new class. We're going to call this pavement. We need to give it a unique value. I know 100's not been used, nor has anything in the 100's been used. I'm going to say, oh, give it a color of gray and then say OK. You can see pavement's been added. This area here in the golf course is dead grass because on golf courses they use a grass that is very good in warm weather, but not in cold winter weather. This is a December image, so therefore this is turned to look dead. So these are the fairways on the golf course. So I'm going to create a new class called fairway. I'm going to give it a value, so I'm going to make that 101. And let's choose something here in a brown type color. And we're going to say OK. And we can see that. You can see here the classes that were there. Planet is already there, so we'll use that for the greens and so on and so forth. So now we have developed our classes, and we can add as many more as we want. Which ones of these actually are on this golf course that we're looking at? And if you notice, forest has got subclasses in it. So we've got some deciduous right here, even though this is December. This is some deciduous, and these are got some deciduous on it. So we're going to use that. So I'm going to use a rectangle as my shape, and I'm just going to click, drag, click, and when I'm done, I'm going to double click on it. There's another one we'll use right there. Okay, we've got a couple different classes. Fairways are going to be pretty easy. Choose that point in the fairway, and we'll come over here and grab another point. So we want to always do at least 2. We've got evergreens. I know this is an evergreen right here, and this may, and there's another one right there. Remember, the cone shaped pieces are areas that are shadows. Planet areas. Well, there's a nice green, and I think that's a green or a tee box. And so we've done some classification there. We're going to go down to pavement. This is obviously a road here. This is a golf path. And a parking lot over here. And so we've done some classifications. Now that we've done our classification, we need to save it. So we're going to save it. I'm going to take it over here to my D drive. I'm going to put in my events folder, and we'll just call this golf and say save. So we're done with our classification. We'll close that tab. We're going to go over here to classification tools, and we're going to click on classify. We're going to open the folder that we put the information in. Put it in my data drive under my name. I don't see it there. I'm going to refresh, and that's the trick here. You got to refresh. I'm going to choose my golf file. I brought that in. We'll leave everything else as it is, and we'll leave the default saving locations, and we will run this. And it takes a few minutes to run, as do most of these geoprocesses. And we'll see how well we classified things. Okay, it has completed the classification. You can see that the fairways definitely stand out. The greens also show quite uniquely in that bright yellow. The roads or the pavement looks like it did a pretty decent job on it. And we can see the difference between the types of trees. They have been uniquely classified, the deciduous versus the evergreen. And so we've done a very quick, very rough classification. So you can see that a schema like this could then be used for other areas, and you wouldn't have to go through a training each time because you've already trained it. Or you might use these categories and do a new training just in the area that you're looking at. So you can see the classification has ran fairly well. I'm going to turn off that layer, going back to our original layer and select it. It's always critical that we select the layer of the raster that we're looking at. And we're going to select segmentation. We can show the segmentation boundaries, and what segmentation is, it's going to look at what is areas that are unique. Actually, we did a segmentation earlier, but this segmentation we will do with colors, so it's another way of classifying things. So it's looking at a pixel and then saying, let's look at all the pixels around that pixel and see if they have a similar signature. And if they have a similar signature, then we're going to say that they're the same thing. And then we'll expand that. And when they're different, then we'll look at all the information around another pixel and see how it compares. So we're going to run this. We're going to use the defaults. Again, you can go into more detail levels. The minimum segmentation size is, we're going to set it 20 pixels. It could be a higher number, which would make it run faster. It could be a smaller number. So you can change that. We will be creating a file as we did with all these others, created a file, and we're going to say run here. And again, as with most of these processes, they don't happen immediately because of the sheer quantity of information. Remember, this information is 3-inch resolution, and so you can see there's a lot of depth of information there. You can see that it has completed the operation and done a segmentation. We're going to run this again. I clicked on the preview button, and you notice that we can actually see the segmentation boundaries. We'll slide back down here and select our original layer. Now we could have ran some of these things also on some of the classification layers that we just did. We're going to go under imagery, under raster function. Note this large set of items that we can do on rasters. We're going to select this NDVI, not the colorized one, but just the NDVI. First thing we must do is select our layer. So we're going to come back here and select this layer here, the one that I originally clipped out of the image service. Band 1 will be red. You can see I have 4 choices there. Band for the infrared is band 4. Make sure you check the scientific output here. And what this is going to do is an NDVI classification, where we're going to compare the amount of red to the amount of near infrared. And we're going to say create the new layer. And so it's done by checking that box that said scientific. It knows that NDVI can only go from +1 to -1. So things that are down here in the negatives are non-vegetative in general. So you can see that we've got these shadows being non-vegetative. We've got the pavements being in this turquoise area, this roof of this building over here. Those are all non-vegetative areas. Things that appear orange are vegetation, so we can see the trees. The shadows are showing up as vegetation, but we know they're really not, and so on. We can come in here and we could play with the ramp color. If we don't like that ramp color, we can come in here and say, okay, let's choose a ramp color that we like better. Let's say we chose that ramp color. Now the greens are definitely the vegetative items, and the browns are the non-vegetative items. We can change our stretch. Again, changing our stretch should not affect our data. And we're going to go to, let's say, standard deviation. That makes it much better that we're now displaying our color breaks using two standard deviations actually of this. We're leaving our gamma at 1. We could also change our label here to be -1 to 1, because that's the full extent, and did a pretty good job of classification. So we can see where vegetative items are. The greens of the golf course. Some of the trees stand out very nicely. These fairways with this Florida grass appear to be dead. They look almost the same as pavement and sidewalks. But you can see how NDVI can be used for vegetative classification.